Hey guys, this is Karan here, living in Saudi Arabia, studying 9th grade in Yambu International School. Today we'll talk about our topic, which is analyzing graph of equation. So what we are going to learn over here is how to imagine graph, okay? So when we first started talking about motion of function, that is when we talked about domain and range of a function, at that time we were talking about in terms of determining domain and range according to the equation we were referring to. Okay, in this graph we are not going to refer to the function itself, and by just looking at the graph it turns out that by just looking at the graph we can find the domain and range of the equation. And let me tell you this, if you look at the graph you can find the domain and range much easier than solving for it. Okay, so if you were to have this equation over here, f of x is equal to square root x plus 2. Okay, the domain here, okay, now what happens is this, if it's plus it shifts itself to negative. Okay, so domain here is x is greater than negative 2, or we can put it at negative 2 to infinity. Okay, the range, okay, the range over here is 0, okay, 0 to any point on y value, and this is infinity, this is infinity. Now I want to talk about functions, which is hard to solve. Okay, functions, last time we were given a value to insert in an equation. Now we won't have a value. Okay, what happens is it looks like one of this equation over here. Okay, there's this. Now the question is, for what values will f of x is equal to 0? Okay. And we have given that y is equal to 0. Okay. For what value of x the whole equation is 0? Well, we know some place over here is the x value and this is the y value. If y equals 0 times any number, it's simply equal to 0. So x happens to be 0 as well. Okay, because it's the x-intercept. Okay, and when we have x to be 0 and y to be 0, okay, and y to be 0, it's at the origin. Now consider that we need to find 0 of this function. Okay, let me use another marker. Okay, we know that the function is f of x is equal to 3x squared, okay, plus x minus. Okay, now find this. Now the question itself says find the zeros of this equation up here. So what we do is plug this value as 0. 0 is equal to 3x squared plus x minus 10. Okay. Now we would factor this thing out. We would get 0 is equal to 3x minus 5. Okay. And then we have x plus 2. Okay, now how do we solve this? Well, this is the easiest part you can ever do. Let me erase this. Well, you have this part over here and this part over here. Okay, so what makes this bracket over here 0? Well, if you have x to be -2, -2 plus 2 is 0, then x over there is -2. And here we need to, all we do is we can't tell by just looking at it like we did over here, but what we do over here is just put this into our algebraic equation. 0 is equal to 3x minus 5. 5 comes here, 5 is equal to 3x. So x then is equal to 5 over 3. So that makes the whole equation to be 0. Okay? Now, zeros of this function, okay? Now we have one more function which you need to find zeros of. If the equation went like this, 0 is equal to radical. So we have 0 radical 10, okay? 10 minus x squared. So what we do is, first this was f of x, okay? So we change the f of x into 0, okay? So when we change the f of x to be 0, and this comes over here, so it's x squared, okay? And this is radical 10, okay? And x is equal to plus or minus radical 10. Okay, so that's how we solve when the function is 0. Let's get back to the functions, that whether this graph is a function or not. Well, it turns out that in this graphical evaluation, it's much easier than algebraic evolution. You know, algebraic, we need to figure if this figure is a function or not. So there is a test called vertical line test, which I'm going to show you here. So by that test, you can tell whether this graph is a function or not. Okay, we're going to apply vertical line test. Okay, when you have a vertical line test, okay, I'm going to show you here. Suppose take this function of this graph over here. So what we do is, vertical line is x-axis like this, okay? So we just make one line. If this intersects at only one point, which is only right here, none other than that, which is only right here, only right here, only right here, and only right here. So when it intersects only one point, because remember, recall the function. What is the definition of function? Like I told you. So if it intersects only one point on that graph, this is a function. Well, if it doesn't, okay, now here's how I'm going to show you. If it doesn't, you might know this, x-axis symmetry. Okay, well, we have vertical line test. Boop. Look at this. 1, 2. 1, 2. 1, 2. This is not a graph of a function. Okay, now let's try some more examples. Let me just draw a graph first so I know what I'm talking. Okay, if you were to have this kind of, okay, the other one is like this, the other one is like this, okay, and the last one is basically this. Okay, now let's do vertical line test if this is function, this is function, this is function, this is function or not. And we don't have to solve this algebraically, okay? Let me just move the camera so you guys can focus on things we are going to learn instead of things. Okay. So we have vertical line test here. So we do 1, 2, 3, 4. Well, it is 1 point, okay? 1 point over here, 1 point over here, 1 point over here, 1 point over here. Okay, this is a function. Now let's do this. Oh, we got 1, 2, 1, okay. 1, 1, 1, 2. Oh, so this is not a function. Okay, let's try this. 1 vertical line test. I'll make it straight vertical lines and check whether it's intersecting at 1 point or not. In this case, it is a function, as you guys can see. Okay, now this line over here. Well, if you guys see that if it's a horizontal line, not a vertical line, what happens is you can tell that it's not a function. Okay, if it intersects at 2 points or more, you can tell that it's not a function. Okay, so now if you do this over here, oh boy, is this a function? Is this a function? Ha, I tricked you. I said vertical line test, not horizontal line test. I said when we have a horizontal line and we have 2 intersecting points, it means it could rather, there's more possibility of it becoming a function, and it's just possibilities. Okay, so if you were to have this, you see 1 point over here, 1 point over here, 1 point over here. So this is function, except this graph, everything is a function. Let me go back and tell you that a graph has a maximum and a minimum point. Okay, so what is a maximum and a minimum point? So consider this graph over here. Okay, you have something like this. Let's say it's this your car speed, okay, and this is on graph. Well, this point over here, this point over here, this point here are the minimum points on the graph. Okay, the lowest point, the lowest value of the graph is the minimum point on the graph, and the highest value is the maximum point on the graph. Maximum minimum. Okay, now relative maximum, okay, it's related to its neighbor. Okay, you guys can see, we can tell that these 2 points are neighbor of each other. Okay, minimum is the same thing, we can tell it's neighbor too. Okay, now this function is rather peculiar notation than graph involves a peculiar as well. So what happens is, I'm trying to say is the function of this graph I'm going to talk about is peculiar, which is strange. Okay, it's rather strange. Okay, we can tell that a graph could be a strange function. Okay, but can we ever tell that a function could be a strange one too? Well, the function is f of x is equal to absolute, not f, the greatest integer of x. Okay, and step function basically looks like this. As you guys can see, I'm posting up on the whiteboard. I need to find. Okay, so does this help? Okay, now let me go back here and try to zoom on it so you guys get the idea. Okay, so now that we have this function, looks like a step function as well, but like you guys can see, we have f of x is equal to the greatest integer of x, which I represented as g of x, But remember, g of x or f of x, it actually doesn't matter. As you guys can see the value, okay, here, if you guys can see, okay, g of x is equal to a whole integer of x. Okay, now if you were to have 1.3, it's 1. If you were to have 1.6, it's still 1. If you were to have 1.9, it's still 1. If you were to have 2, it's 2. If you were to have 2.2, it's still 2. So the whole concept of step function, which is basically this graph, which looks like a step. Okay, let me zoom it. Okay, so it basically looks as a step function as well. And here I'm going to show you when this graph, or when this kind of graph is being used. Okay, so I would go over here, and this over here is very useful graph, but you guys might not know this. How is it useful in daily life? Well, let me remove this graph and try to show you some examples. Okay, well, the first oral example that I'm going to take, like by speech, what I'm going to give you guys an example is that this kind of function are being used by your telephone company, and a lot of different companies, such as TV, not TV actually, it's basically cell phone on top of my head. Okay, so suppose if we were to have 60 cents, okay, if your cell phone company says that you can talk for a minute for 60 cents, 60 cents for 1 minute. Okay, and then you have additional 40 cents for additional minutes. Okay, now how are we going to make the equation? Well, we have cost, we need to pay cost, we need to find how much. Okay, so we do 60 cents, that is always included. Okay, so we do cost plus the greatest integer value, okay, times 40 cents. Okay, so what do I mean by greatest integer value? Well, if you were to have 1.9, even if it goes 1.9, like suppose you talk for 1 minute 90 seconds, what happens is you're still charged for 2 minutes, not 3 minutes. Okay, so if you talk for 1 minute for 60 cents, and then you went over 1 minute, okay, if you go over 1 minute, so what happens is 40 cents are being applied to 60 cents as well. So 60 plus the whole integer value times 40 cents. So that is how we make the cost equation. And you can make this cost equation and find out how much do you have to pay for your cell phone company. Okay, now function can be classified even and odd for the function that is related to the idea of function. Symmetry can occur in 3 different ways. Okay, so I want you guys to know that symmetry can occur in 3 different ways. If you're watching this video after watching my symmetry video, it will be so much easier for you. Okay, the first symmetry is called y-axis symmetry. Second one is x-axis symmetry. Third is origin symmetry. If you haven't watched these videos, I recommend you to go right now and watch these videos right now. Okay, because then you won't have any idea of what I'm going to talk to you. So let's say for x-axis symmetry we have a graph like this. Okay, this is y-axis symmetry because it's going like this, left to right or right to left. It actually doesn't matter. How do you know that if it's a symmetry? Well, I have talked about this point over here, which is some arbitrary point, which is x and y, and when you flip it, what happens is you have negative x and y. Well, if you were to have this equation over here, let's say y is equal to x squared minus 3, okay, and what happens is the x becomes negative, okay, so y is equal to negative x squared minus 3. So negative, any numbers that is square, whether it's negative number or positive, it still comes out to be positive. So y is equal to x cubed minus 3, and this is identical to this. So you can tell that this is y-axis symmetry. Okay, now for x-axis symmetry, I would like you, if you have watched my previous video, there's new example. Okay, and this is very good example I have brought. If you have something like this, it's still x-axis, right? You're folding it. Okay, that is for x-axis symmetry. Now, origin symmetry. What is origin symmetry? If you were to have, okay, this is the origin symmetry, and this is a new example as well. So what is it saying is it's actually a double fold symmetry. Okay, so if there is a double fold, okay, now if you were to take this point and reflect it over y-axis and then flip it over x-axis, it would be origin symmetry. Okay, and basically here I have taught you that how to calculate symmetry, I mean the function, whether a graph is a function or not, by just looking at it. So as you guys have seen that without using any numbers, we just found out that either this graph is a function or not. So I hope you guys like this video. Please go ahead and subscribe, like my video, comment so I know your feedback. Okay, thank you.